Just to go over the calendar really quick, again, happy Memorial Day to everybody. Thank you all for serving your country, and that's why, honestly, that's why we're here and why we're in business, to serve you guys. So assessment 3 is due this morning. So when you get a chance, no rush. I'm not like saying like, oh, he or she opened it at like 10 a.m. or something like that. I just want it pushed up so I can start grading it. This morning at 10 o'clock, Chris Walquist is going to be coming in to do his second part of Git part 2. The road home is going to be coming in tomorrow morning, and I finally got them in the calendar. The road home is a mental health servicing organization. It's part of Rush Hospital. So in the case that you or your family ever needs any sort of mental health services, or you want just somebody to talk to, it is completely free for veterans. And if you need to go there for any reason, and you need us to cover the cost of an Uber or something, discreetly email Rod or myself your receipt, and we'll get you out there. But they'll come a little bit tomorrow morning and talk about the services that they provide and why they do it. So just know that in the case that you do need free mental health services, it is available for you. Alex's last day is in 2 days. Afterwards, he's going to be doing, I think, National Guard training for a couple weeks, and then he's starting his job at Aon. And then we're going to have our Beyond Tech Personal Finance Part 1 on Thursday, something that I like to talk about quite a bit. And then as you realize, we're not doing a ton of algorithms anymore. We've been, like, the first 2 or 3 weeks was basically all algorithms, but it is something that you do need to continuously keep up with. Otherwise, by the time you get to whiteboarding, you're going to get, you might get crushed. Who knows? There is a book on Rod's desk called Cracking the Coding Interview. If you want to borrow that, it's in the back of the room. It's so huge. It's basically the coding interview Bible. If you want to read that, we'll check them out for about a week at a time. Just let me know who has it at any point so that we can hand it out to you. We can get extra copies if need be. We do not.
But there's also that site.
There's also the site, yeah. There's also Interview Cake. And finally, we're going to have some people starting to come in to teach whiteboarding to us. So there's going to be different senior devs. Like my strength is not in whiteboarding. Like I've done them as an interviewee, but have not done it as an interviewer terribly often. I've done it maybe 5 times. But we're going to have some more senior developers coming in. So this week will be Toby Tripp. Then the week after will be Don. There's a few other people. I think Brian Willard from Google is going to be helping us out with some of that as well. But if you want to be part of that, it's going to be from 2 to 4-ish this Thursday. And Toby's your mentor, right, Tristan?
Yes.
Yeah. So he's going to be coming in on Thursday to teach this stuff to us. There's a few things I want people to do this morning for the first half hour. One is feedback forms. How are you feeling? We're almost at the halfway point. Halfway point is right over here. Next Friday is going to be pretty much the halfway point. We're going to have all the fundamentals that we need to start building web apps. So in about less than 2 weeks, on June 11th, we're going to start building our first web app, which is fairly exciting. I do want to know how you're doing, so fill out those feedback forms. Work on your LinkedIn. And the new question for this particular week is, tell me about a time that you had to work on a team. Now, this particular question is very, very popular. There's going to be any variety of things where it's like, tell me about a time that you had to collaborate with somebody. It's the same question as tell me about a time you had to work on a team. Tell me about a time that you had to work with other people to achieve a certain goal. These are all variations of tell me about a time that you worked on a team. Because software, while you do write by yourself, the software that you write, like Mark Zuckerberg does not write Facebook. Like he doesn't do anything with writing the software for Facebook anymore. He has teams of people doing it. And only by working on teams of software engineers are you actually able to build anything worthwhile. So there's a few things when it comes to talking about teams. I generally just go with the STAR method: situation, task, action, and result. I worked on a team in, college. Don't go that far back. I worked on a team. We were tasked with doing this particular thing. We took this particular action. As a result, revenue went up 5 million%. Something along those lines. People like to hear a general story about how you work on a team and the role that you played on that team. So 3 things for this morning. I'll put it in the Slack channel. One is those feedback forms. 2, work on your LinkedIn. I'm just going to start picking people's LinkedIns, all 5 of you here, and then the 2 remote students that I see. I'm going to start picking your LinkedIns up here and just kind of giving you some feedback in about 10 minutes. And then working on that behavioral question. Tell me about a time that you worked on a team. Situation, task, action, and result. Today and tomorrow, we'll work on full-length prose. Just write out everything that you would need to. Thursday, we'll dumb it down to bullet points. Friday, we'll practice. Next week, we're getting another question. Please do not ignore the behavioral questions. Again, the behavioral part of the interview is probably worth 60% of the first job that you get. All right, with that, we'll get started. All right, so over the next couple weeks, weeks 5 and 6, there's a variety of topics that are going to be covered. I'm going to cover HTTP and cookies and sessions and how the web works and things of that nature. Also going to be covering HTML and CSS and Bootstrap and all of these things. Now, there are things that we consider to be absolutely crucial, absolutely core to your learning here, things that you need to know in order to get a first job. Things like, how do I write an algorithm? Loops, variables, how to write a method, SQL, SQL. Those are things that you absolutely need in order to be able to get a job. Things like object orientation. Then we get into things like how the internet works, HTTP, the theory behind a lot of how a lot of this actually functions. Things like HTML and CSS you need to have a basic understanding of, but I have a very basic understanding of it because I just don't write a ton of HTML and CSS. I can get around, but I just don't know a lot of it. And I found that as long as you're able to intelligently answer things about front-end technology, they're not going to be like, what is the HTML tag for the largest header, right? Like no one's going to ask you the questions like that. Like that's something you can easily Google and look up yourself. And with that, the next couple weeks, I would consider more or less retracking weeks, what we call retracking weeks. If you are struggling with anything in terms of front end, like algorithms or object orientation or SQL or anything like that, the next 2 weeks is a good time to go through it. And how this will function is we'll just have class as usual. We're not going to be pairing over the next couple weeks. So we'll have class as usual. I will teach whatever needs to be taught so that you have a broad introduction to it and that you're at least understanding things when I talk about what's a GET request or a POST request. But you'll have time in the afternoon to either work on the challenges for the day, or you can go back, work on your previous assessments, work on different aspects that you are struggling with. So more or less the next 2 weeks are open for you to figure out what you need to basically get better. But if you want to stick with the regularly scheduled programming, we're going to be doing HTTP and how the internet works today, and then there's challenges associated with it. Tomorrow we'll talk about cookies and sessions. There's going to be a challenge associated with it. You can choose whether or not you want to do that work on your own. Let's talk about HTTP really quickly before Chris gets in. So we're going to talk about HTTP, which is how information is transferred across the entire web. So HTTP basically connects the world. It stands for Hypertext Transfer Protocol, and it's the transfer protocol of how you would just give hypertext over the internet. The original protocol was originally created in 1991. And hypertext goes back as early as 1930. We generally don't do a ton of hypertext anymore. The modern equivalent today is HTML. At the very end of the day, everything is HTML, JavaScript, and CSS on the front end. You can do whatever languages you would want on the back end. You can have Java, you can have Python, you can have Ruby. Doesn't really particularly matter what you have on the back end. In the end, everything that comes in on the front end is all HTML, CSS, and JavaScript. But you can also use the HTTP protocol to transfer files and documents, CSS, JavaScript, anything you would want to get over the internet, you're going to use the HTTP protocol. That's what's powering everything. John?
Because everything's inside of the window object, isn't it ultimately JavaScript?
Yeah, we can go back and forth on that one. All right, so HTTP, when we talk about HTTP, there's two parties involved. There is a client, the person making the request, and the server, which is the thing that's responding to the request. So if I walk up to Ed and I stick my hand out, I'm the client. I'm the person making the request. And then Ed, as the server, can choose whether or not he wants to shake my hand or not. Like, he's going to give me some sort of response because he's the person responding. So your client, which is your Google Chrome, your Mozilla Firefox, your Safari, your Internet Explorer, you'll send an HTTP request, and then the server sends an HTTP response. Again, it's just a request and response cycle. That's all the entire internet is. It's just me, I'm making a request to someplace, and I'm getting some sort of response back. That's all that the internet is. It's very similar to just having a conversation with somebody. If I walk up to James and I say, "How you doing today?" I'm initiating a request. He's going to hear that inside of his brain. He goes, "Oh, I've heard that question before." He does all the language calculations of like, "Oh, this is what the person is asking me." And he's going to respond with, "I'm doing great today." That's the response that I get back, and that's it. Similarly, when I go to google.com, I'm the client. I'm making a request to Google. Google hears it, does a bunch of stuff on their back end, and shoves me back a page that looks like google.com. So on the left, we have a request, and on the right, we have a response. We're going to go over each and everything that we have over here. So inside of the request, you start off, the first line of every single request is this request line. You have a method, followed by a URI, followed by a protocol version. And we'll go over each one of these things in fairly good detail. The first thing we're doing is on your request line, you're asking for a specific HTTP verbs. So you're saying, I'm making a GET request to /bio.html with this particular protocol version, or I'm making a POST request with this particular information, or a delete or a head. The two main things that you need to know is GET, fairly self-explanatory. GET, I'm getting information from somebody. So when I visit a website and I go to apple.com and I press enter, that's making a GET request. I'm saying, me as a client, I'm Google Chrome or something like that, I'm making a request to apple.com to get me all the information on apple.com. So it's basically saying, please get me all this stuff. Posting is when I'm sending stuff over. So when you're filling out a form, when you're creating when you're signing up or you're logging in or something like that, you're sending data over the internet. Instead of you just saying apple.com enter, I'm filling out a form and pressing submit. I'm taking all that data inside the form, packaging it up, and sending it over to the server to do something with it. So every time you log in, every single time you sign up, every time you place an order, you're making a post request because you're sending stuff over. Delete, it's like, I want to delete my order, I want to delete my record, I want to disassociate myself, please delete my account from XYZ. I'm sending a delete request over. And then head, I'm retrieving information about the resource, but not the resource itself. So it's kind of like looking it up in the phone book, who lives at this particular address, rather than sending information over. The two big ones are get and post, and then put or patch, and then delete. I didn't put patch in here. Put and patch is when I send data over to update something that doesn't exist. So get, I'm getting I'm getting stuff from the server. Post, I'm sending stuff over, usually new things. And then put and patch, I am updating something that already exists. Delete, I'm deleting something. So, John, what's a GET request? What does that do?
You're pulling information from something to do with HTTP is giving you some sort of plain text information. You're pulling it to your its response is what you're pulling out of, is what I'm getting so far.
No. Okay. So a GET request. So I'm making it's basically I am going up to Michael and saying, like, tell me about your parents. So I'm asking for him to give me information, and that's it.
Okay.
So it's when I make a GET request as a client, I'm saying, give me some sort of information from the server. That's all it is. Just get me something. Michael, what's a POST request?
A POST request is, wait, what was it? It's get, post, right. So POST is send in a resource.
What does that mean?
It means that once the GET request is sent, it reads the GET request to see what you want and it responds appropriately.
Close, kind of. So a GET request, as I said, is just I'm getting information from someplace, right? When I go to google.com and press enter, that's a GET request. Like literally when I just go inside of google.com, I press enter, I'm not sending over any information. I just say, I'm making a request to google.com. Google.com responds with all of the HTML, all the pictures and all the links and things like that to make up this particular page. I'm just getting information. Posting information is when I go I want to look up a non-government 457 plan, which is what I was looking at this morning for fun. So I'm sending over information. I filled out a form and I press send. I'm sending over information from my client over to Google. When I first did that, google.com, oops. When I first went to google.com, I just made a GET request. Just give me a bunch of information to come back to me. When I fill out a form and press Google search, I'm posting information because I'm actually sending something over. What about James, what about a put request, put and patch?
Is that where you're altering?
Yep, I'm altering something that already exists inside of the database and then delete it. What is delete? Yeah, I'm just deleting something from the server. So the first part is the request, like verb. I want to get something, or I want to post something, or I want to delete something. That is the first thing that you're always going to need to do. The second thing is that comes is the URI, the Uniform Resource Identifier. The URI is not a URL. A URI is like the very, very last portion after the .com or the .org. So Code Platoon /jobs. The /jobs is the URI. A URN includes the host and the URI. So codeplatoon.com/jobs or example.com/bio.html. And then the entire URL consists of the protocol, which is HTTP, plus the host, plus the URI. So 3 different things. The very end is the URI. Everything after the .com or the .edu or whatever, that is the URI. The host is your codeplatoon.org, google.com, amazon.com, apple.com. And the URL is the entire thing. So HTTP, www.apple.com/products. That is the entire URL. And you'll see at the very beginning of all of these things, there's either going to be an HTTP or an HTTPS. What is the difference between those two? What's that? Yeah, one's secure and one is not. When you have HTTP, it's not secure. When you have HTTPS, all the information that's being sent and received is encrypted. So you should feel safer by doing that. So let me show you something really kind of funny. I don't know if they still have it. They might not have it anymore. Nope, they don't have it anymore. So they finally made this HTTPS. So this building, in order to reserve rooms, we had this old HTTP URL, and they told me to sign up using my email and my password. And I noticed it was HTTP, so I was like, I want to see if I can just see if other people can see what my username and email and password are, and you're able to see it completely in plain text. When you do it via HTTPS, it's being encrypted. So again, all we've covered so far, HTTP is just a way that we talk over the internet. It's a request and response cycle between a client and a server. You are the client, the server is google.com or amazon.com. When you make a request, the first line includes the method, the URI, and the HTTP protocol version. We're still on 1.1 for everything. It's basically like saying at the very, it's similar to you staying at a hotel and they say, is this trip for business or for pleasure? They want to know like how they can best serve you, so they're going to get some information ahead of time. when I make a HTTP request, it's kind of ambiguous. Am I sending data? Am I getting data? You need to be very explicit with that right off the bat. So if I'm saying I need to get some data, I'm retrieving a resource. If I need to post some data, I'm sending something over to you. Put and patch, I'm still sending something over to you, but I'm updating a record that already exists. And then delete, I'm deleting a resource from your server. URI we talked about, URN, URL we talked about. So that's the first line, the request. Then we have something called headers. Headers will include the host of like what website you're trying to go to, and the user agent of like what is making the request. So when you go on your computer and you make a web request, your computer is going to give you a response that looks a little something. If I go to apple.com, you'll see that apple.com comes out looking beautiful like this. It fits my entire screen. It's meant for a laptop. But when you make a similar request inside of your phone or with a tablet or something, it's a different size. You might not have all this stuff at the very top. So you can kind of see as I bring this closer and closer in, the screen automatically adjusts to where I'm making a particular request. At this point, I'm inside of a mobile view. So if I were to make another request to this apple.com with this particular window size, it thinks that I'm in mobile because there's different responses based off of like what size of like what's making the request. A Google Chrome on mobile will show up more or less like this, where a Google Chrome in desktop will look something like this. Again, Again, this is just high-level overview. We'll cover it more, and it'll make more sense later. So that was the example of a GET request. When you are posting stuff over, it looks a little bit different. So I got the HTTP verb. I'm saying I'm sending over information to /search with this particular protocol. The host that I'm sending it to is example.com or zappos.com for shoes. I'm saying that I'm Google Chrome 5234. This is the version of Google Chrome that I'm sending it over, and this is what I'm actually sending over. Inside of there, here's the body, which is the query is new Jordans, and the color is red. You can kind of think of this content type as more or less a manifest of like, what am I sending inside this box? So when you send something via USPS, they're going to basically say, like, what's inside of here? Is there lithium-ion batteries? Is something going to blow up? Is there something fragile inside of here? They want to know what's inside. So that's what's going on inside this content type here. I'm saying I'm sending over an encoded form, and this is the information that's inside that encoded form. Real quick, if you go to, I don't shop at zappos.com. If I go to zappos.com, this might take a long time. And let's say I'm looking for comfort sandals, sure.
They look very comfortable.
They do. When I go to zappos.com and I right click, or when I go to any particular site, I hit on this. All right, let's forget about this for a second. Let's just go back. All right, so that's an HTTP request with a body. You can also make HTTP requests with query parameters. So it's kind of like if you wanted to save a search, like if I go to Amazon.com and I want to look up, Instant Pot or something like that, I can fill in the Instant Pot, like inside the form, press the search button, and that's going to send a post request. The URL is going to change at the very top. Actually, let's just do that. Let's go to that. Amazon.com. So right now I've made a get request to Amazon.com. I just said, I want you to load the entire main page and this is what comes out back to me. If I want to look up for an Instant Pot, I fill out this particular form and I press the submit button. At that point, since I'm sending information over to Amazon, I'm making a post request. At this particular point up top over here, in the case that I ever want to come visit this ever again, I can copy and paste, just put it inside of here, and now I'm making a GET request with these extra query parameters. The way that you know that you have a query parameter is this little question mark inside of your, everything that follows the little question mark makes it a query string. So you can kind of see, I've got a query string because there's a question mark at the very end, and the URL is, I'm going to search for keywords Instant Pot. This is how they know like exactly what you've searched. And if I pass this URL off to you, this particular thing, this particular search bar would also have Instant Pot built in because it's inside of the URL. So there's a few headers that are sent over via HTTP. And again, now you can kind of see like why I said this is like nice to know, but not absolutely crucial because there's a lot to memorize. There's a few request headers that I have that we send over every single time. So if I walked up to, if I walked up to Ed, right, and I'm walking over, actually no one can see me from over there. If I walk up to Michael, and I got a big smile on my face. Michael, how you doing today?
Good.
Yeah. So he smiles a little bit because there's some nonverbal communication happening, some nonverbal communication that's going on. He knows that in his head, like somebody's approaching me. If they have a smile on their face, their hands extended, their fists are not clenched, so I don't need to tighten up. But if I were to come at Michael like real fast, right, and my hand is cocked like this, he'd react in a very, very different way because he sees that there's some headers being sent over. Like I'm sending over like an act of aggression. I'm sending over coming at him real quick. My hand is like cocked back like this, so he knows I need to protect myself. There's some unsaid things, and that's how humans like interact. There are things that we send non-verbally. Computers are not like that. So computers need to know literally everything that you're sending over. Again, computers are very fast, but they're very stupid. So it's when I speak to when I'm in America, like I speak English. That's how I get around, right? This is a bad example. Let's go back to the example of me like saying hello to Michael. When I smile at him, I put my hand out. He knows that like, oh, I've got nothing to fear. This person is like, this is like he's trying to be nice. When I come at him real aggressively, I got my hand cocked and my teeth are clenched and stuff like that. He knows this person is coming at me very aggressively. That is not the way that computers work. That you need to tell literally every single thing that you're sending over. So these are some examples of headers that are sent over every single time that you do apple.com or amazon.com. First, you need to tell them what host you're trying to visit. Because again, HTTP is just a protocol. It's just saying like, where would you like this request to go? I'd like it to go to apple.com. I'm only willing to accept English as a response over here. And this changes per country. So JP is Japanese, CN I think is Chinese, Spanish is SP. Like based on the accept language, that's what the server is going to respond with. Like if I say hello to Michael, I expect English to come back. That's a nonverbal thing. In terms of computers, if I say hello to a Chinese website, they're not going to be able to say hello back in English. Like unless I say accept language is going to be English. The user agent is basically saying like what type of machine is making this request? Is it a phone? Is it a computer? Is it a tablet? Is it an Apple Watch that's making this particular request? And that will determine basically number one, how large the screen that comes back to you and what it looks like. And also helps them figure out like all their metrics of like who's actually making requests to the site. So when Amazon, like since they can log every single request coming in, they know, 90% of our users are from mobile and most of them are for iOS. So when we make a new feature request, we're going to make it for iOS first because that affects the majority of our customers. And then what am I willing to accept? Like what format am I interested in receiving things back? Plain text, HTML, and that's what's going on here. Next, let's talk about the response, and then we'll take a break. So I sent a request over HTTP, and I'm getting a response back. It's broken down like this. The first thing is the status line. I get a code that comes back, a reason phrase, and then an HTTP version. Again, it's still 1.1. Now, there are, I don't know, hundreds, dozens, we'll just say dozens, at least dozens of status codes. But the main thing that you need to remember is the first number that shows up on the left. Anything that's a 200 is okay. Anything that's a 300 is a redirect. Anything that's a 400 is a bad request. And then 500 is internal server error. You can think of it as like you walk up to somebody in a bar and you say, like, you're attractive, I'd like to ask you out on a date. If you get a 200 response, that's yes, I'm also interested in you. 300 is, I acknowledge that you said something to me, but let me introduce you to my friend. So it's like, I acknowledge that you said something, but have you met Ed? You know, like, have you met Ed? 400 is just no. Like, you walk up to them, I find you very attractive, would you like, can I buy you a drink? And they just say no. That's a 400. Something on your end went wrong. Maybe you didn't shower, maybe you didn't, it doesn't matter whatever the reason is, but it's 400 just means no. And then 500 internal server error, it's usually when a website is down. So it's like, it's not you, it's me. I'm sorry I had bad sushi last night, or, you know, I have indigestion, or something went wrong inside of me. So again, it's almost impossible to memorize every single one. Hey, Chris.
Yes.
But again, 2, 3, 4, and 500 status codes. 200, you walk up to the nice person at the bar and you say, can I buy you a drink? Yes, yes, I'd love to go out for a drink with you. 300, have you met Ed? Have you met my friend? Let me redirect you somewhere else. You ask the person, can I buy you a drink? If it's a 400, it's just no. Something went wrong on your end. Like, I don't care what it is, but the answer is no. And then 500 is something's wrong. It's not you, it's me. Bad sushi, indigestion, not a good time, et cetera, et cetera. So 2, 3, 4, and 500. You don't need to memorize every single one. You just need to know the first number, the HTTP status code series. When the HTTP response comes back, you're going to get some headers along with it. Again, it's just text going to the server and text coming back from the server. Your Google Chrome does a lot of heavy lifting. This content type determines what type of, like, what format stuff is coming back to you in. Is it going to be an image? Is it going to be plain text? Is it going to be JSON? Is it going to be HTML? That's the stuff that's coming back. How long is the thing that you're sending back? How many bytes long is the response that's being sent? Is there a cookie that the server is telling you to set inside of your browser? And then the date that something occurred. When I go to any sort of web page, like let's take Target, for example, when I make one simple request to target.com, there's a lot of things happening on the page. And let's take a look at that right here. Let's go to target.com. And I just did one thing. I went to my Google Chrome and I made one simple GET request to target.com, and I got a whole bunch of things back. Let's take a look at what those whole bunch of things look like. When I right click, I hit inspect, and I go to sources. Where is it? Network. There it is. So when I go to network over here, let me just refresh the page right here. I'm going to clear out everything. And I'm just going to go to target.com. Again, I just made one request to target.com. Target.com, in turn, makes a whole bunch of different HTTP requests on the back end and then feeds that all back to the front. And all of these requests are still being made when I make a request to target.com. So I waited about 2 or 3 seconds. You can see in the background when I made one request to target.com, there's many HTTP conversations happening. There's actually as of right now, 125 requests. And these are all the different things that are happening. I don't know what half of these things mean, but you can start to see the size in terms of bytes. This is how long it took. Did I get a 200 status code? It looks like everything is looking pretty good so far. I saw a 304, so you really know that this is a redirect in some way. And all of these HTTP conversations are happening on the in one small little request. And that's generally what's happening. Last few things, and we'll take a break. The HTTP, every single request that you make over the internet is stateless. And what that means is that every single time that you talk to the server, it's as if you've never talked to the server ever before. So you can think of it as the classic 50 first dates. If you're not familiar, Adam Sandler and Drew Barrymore, like Adam Sandler sees Drew Barrymore on this island and finds her very attractive, but she has like short-term memory loss, long-term memory loss. So every single time, even though they've met on numerous occasions, it's as if it's the first time that they've ever talked together. And that's the way that we think of the web. Everything is stateless. So when I make a request to google.com, I probably go to google.com 100 times a day, to go do different things. Every single time I make a request, it's as if it's the first time I'm making a request. It doesn't save any information about me, and it's a fresh connection every single time. But you might be wondering, like, that's a really crappy user experience. Like if I go to Amazon.com and I have to, they don't have any of my saved orders, or they don't know who I am, and it just says hello random name. I want to see hello Jonathan every single time that I log in. So the way that the people take care of that is when I make a request to the server, to Amazon, and it comes back, they send me back cookies, and that's saved inside of my computer, inside of my Google Chrome. So every single time I'm making subsequent requests, it also sends over those cookies so that it knows, like, hey, it's Jonathan making this request. Hey, it's Jonathan making this request. So I don't have to continuously log in and log out all the time.
Is that a design for from a security perspective, or is that an efficiency perspective, or both? Or
Which one do you think? If you had to guess.
Well, I mean, the security jumps right out at me, but
Mm-hmm.
I can understand from an efficiency standpoint, it would also be beneficial.
I think it's both. I think it's mostly the former. It's a big security thing.
Right.
So by making every single HTTP request stateless, meaning that it's a fresh request and response every single time, you're able to guarantee a little higher level of security. Chris, do you have anything on that one?
Yeah, so the internet was, it was a Defense Department project, and they wanted, part of the driver for the project, as I understand it, was they wanted to make it fault tolerant. Right? It was distributed in nature, so there's no centralized point of failure. So this protocol supports that goal as well.
Okay, makes sense.
Let's see. Okay, so a quick summary on cookies. We'll talk about cookies tomorrow, but basically your server, when you make a request to Amazon.com, will set cookies and send them back to the client or your Google Chrome or your Firefox as part of the HTTP response. Your client, meaning your machine, you store the cookies. Server doesn't store any sort of cookies, and then once you make any subsequent request to that server, those cookies are also sent along. So that it's like, hey, keep me logged in for 2 weeks, and you click that little box. How does this? The server doesn't keep track that you've been logged in for X amount of time. They send a small little token that will expire at a certain point. So that every single subsequent request that you make over is going to say like, oh, like this is the token that's good for the next 2 weeks, and that's how they do that. So in summary, HTTP is the protocol for the entire web. You make a request and you get a response. The client makes a request, the server gives a response. You make get, post, put, patch, and delete requests most of the time. And then from there, you'll get a response with a 200, 300, 400, or 500 level status code. 200 is yes, 300 is talk to my friend or a redirect, 400 is no, and 500 is internal server error, bad sushi, indigestion, whatever it is. Nope, like something's wrong with me right now. With that, we'll take a quick break for about 10 minutes, and then we'll be back for Git Part 2.